Okay, so in this video here, we're going to be talking about solving a 2x2 system of equations, and we're going to be using the elimination method. Okay, so a 2x2 system of equations, what that essentially means, that means you have two equations and two variables, and you're trying to figure out where these two lines are going to intersect. Okay, we call that your solution. The intersection point is going to be your solution. So I have three examples down here before we start these problems. So if you have two lines and they intersect at one point, that's going to be called one solution. All right. If you have two lines and they're parallel, meaning they do not intersect, that's going to be no solution. And then if you have two lines that are exactly the same, meaning they're always crossing, that's going to be infinite solutions. Okay. So when you're solving a 2x2 system of equations, you have three possibilities. You could have one solution, no solution, and infinite solutions. Now we're going to use algebra to solve these. We're not going to graph these lines. We're not going to graph them and figure out if they intersect or if they're parallel or if they're the same line. We're simply going to use algebra to solve these problems, and that is the elimination method. So let's go into our first problem. So here's our first problem, and you can see that both of these equations are in standard form. Typically, when you use the elimination method, you're using it because both of your equations are in standard form. Now, you could use other methods such as substitution, assuming that maybe one of your variables is isolated, but that's going to be for a different video. We're just going to be talking about elimination here. So the goal of elimination, you're either going to do the problem as one big addition problem or one big subtraction problem. It's not a right or wrong way how you do it, but you have to stay consistent on how you do it. So if you decide to do addition, you have to do addition all the way through. If you decide to do subtraction, you have to do subtraction all the way through. So let's take a look at this one here. What do we need to do first? Well, the goal is to eliminate a variable. And you can see here I have a negative 14x and a 7x. So if I were to do this as one big addition problem and I were to multiply this bottom equation by 2, that would give me 14x right here. And then if I were to add it all up, I'd get negative 14x plus 14x, and that would cancel out my x variables, and then I could solve for y. So again, when you're using elimination, you're going to do it as one big addition or subtraction problem. Okay, so for this example here, I'm going to take this second equation. Let's go ahead and label it. So equation 1 and equation 2. I'm going to take the second equation and I'm going to multiply it by 2. Okay? So I'm going to rewrite the first equation. I have negative 14x minus 4y equal to 4. Now that second equation, I'm going to multiply everything by 2. I get 14x minus 12y equal to 12. Okay? So now it becomes one big addition problem. I'm going to do a line right underneath, and we're going to add it up. Negative 14x plus 14x, that cancels. That's what we want. That's the elimination. Okay? Now here, I do negative 4y plus a negative 12y. That gives me negative 16y. So remember, we're adding all the way through here because that's what we did at the beginning. So we have to stay consistent. And here I'm going to do 4 plus 12. I get 16, positive 16. My last step, divide both sides by negative 16, and I will get my y value. Okay? So I do 16 divided by negative 16, and we get y is equal to negative 1. Okay? So that's the first part. Now the second part, I have to figure out what the x value is going to be. Remember, this is a point. When you solve a system of equations, you're looking for a point. So right now I have the y value of that point. I need to find the x value. Now to do that, you simply take your y value right here and you plug it back into either equation 1 or equation 2. It doesn't matter. And you solve for x. So you always want to pick the easier of the two equations when you substitute back in. So for this one here, I'm going to plug y into equation 2. Okay? It looks easier to me. So using equation 2, I'll have 7x minus 6 times y, which is going to be negative 1, equal to 6. Cleaning it up, we get 7x, and negative 6 times a negative 1 will give you positive 6, equal to 6. From here, we want a minus 6 on both sides. This will cancel. Here, I get 7x equal to 0. Divide both sides by 7, and you get x is equal to 0. So the point here, or the solution, is going to be 0, comma, -1. Remember, this is x and this is y. There is my solution, okay? So let's try a couple more problems here. Okay, so here's my next problem. What do I want to do here? So here's equation 1 and here's equation 2. What variable do I want to eliminate? And it's not a right or wrong answer, but you always want to look for the path of least resistance. So looking at this problem here, I have a -3x and a -2x. In order to make that cancel out, I would have to multiply the top one by a +2, the bottom one by a +3, and then I would have to do subtraction to get it to cancel out. Whereas if I look at the y's here, if I just multiply this equation 1 by 3, and I do it as an addition problem, the y's will cancel out. So that's what I'm going to do. So multiplying the top one by 3, I get -9x, +12y, equal to 81. Okay? Now the bottom one, I don't have to do anything with. So just going to rewrite it. And so now we're going to do it as an addition problem. -9x, -2x, when I add that, I get -11x. This will cancel, that's what we want. And here I have to do 81 plus a -26. That will give me 55. So equal to 55, divide both sides by -11, and we will get our x value here. So x will be equal to -5. From here, we just want to go ahead and plug it back in. Which equation looks easier? Well, let's do the top one. So I'm going to do -3 times, here's my x, I plug in -5, plus 4y, equal to 27. So cleaning it up, right here I get +15, plus 4y equal to 27. Now I want a -15 on both sides. Okay, this will cancel, I get 4y. 4y is equal to 27 plus a -15. That will give me 12. Okay, and so you can see here my last step is to divide both sides by 4. 12 divided by 4 will give me 3. So y is equal to 3. So putting it all together, I have a point now, x comma y. So it will be -5 comma 3. And that's done. Okay, so that one has one solution. That is where they are intersecting. Those two lines are intersecting at -5 comma 3. Okay, so here's my next problem. Again, always look for the path of least resistance. Let's go ahead and label our equations. This will be 1, this will be 2. And so looking at equation 2, if I just multiply everything by 2, I can get the x's to cancel and the y's to cancel if I do a subtraction problem. So for example, if I multiply this by 2, I'm going to rewrite the first one. I don't need to change anything there. So just rewriting it. And then equation 2, if I multiply by 2, I get -6x, -4y, equal to -14. And so what happens here, you can see that I have exactly the same thing. Those lines are both the same, meaning I already know the answer. If they're both the same, that means they're always going to be intersecting. They're right on top of each other. This is going to be infinite solutions. Infinite solutions. Okay, that's it. And so I just want to go through the problem though so you can see what would happen here, right? If we were to do this as one big subtraction problem, because that's how we're going to get these variables to cancel out, a -6x minus a -6x will give you 0, right? So write it out if you need to. -6x minus a -6x, right? Two negatives make a positive. You can see that it will cancel out. All right, so be careful when you're doing these subtraction problems. They can get kind of wacky with the negative signs, but this will cancel. Same thing will happen here. This will cancel. I'm left with 0 equal to -14 minus a -14 will give you 0. So you can see here that when the variable drops out, you have two possibilities. It's either going to be infinite solutions or no solution. And how you determine that is once the variables drop out, if you are left with a true statement, it's going to be infinite solutions. If you are left with a false statement, it's going to be no solution. Now you can see here, I am left with a true statement. 0 is equal to 0. That tells me that I am dealing with infinite solutions, meaning they are both the same line. Okay? Let's try one more problem. So here's our last problem. Let's go ahead and label everything. This will be equation 1, equation 2. Always look for the path of least resistance. Now in this problem here, I'm going to eliminate y, because if I do it as a subtraction problem and I multiply this second equation by 2, they'll cancel out. All right, so I am going to go ahead and multiply this bottom equation by 2. So rewriting the first equation, I get negative 12x plus 12y equal to negative 4. Don't have to change anything there. Now multiplying the bottom equation, I get negative 12x plus 12y equal to negative 12. Now look what happens here. Remember, we have to do it as a subtraction problem. That's what we determined from the beginning. I'm going to do negative 12x minus a negative 12x. Again, those two negatives make a positive, so it's really like negative 12x plus 12x. That will cancel out. This one here, remember, we're doing subtraction. 12y minus 12y. That will also give me 0. That cancels out. The whole left side is going to be 0. Equal to negative 4 minus a negative 12. Well, remember, those two negatives make a positive. So if I do negative 4 minus a negative 12, my two negatives become a positive. That will give me positive 8. And so I'm left with this statement here. We just talked about it in the previous example. Both variables dropped out. Now I have two possibilities, either no solution or infinite solutions. Now this one here is going to be no solution because I am left with a false statement. 0 is not equal to 8. As a result, this will be no solution. Okay? And again, we know that if we have no solution, we're dealing with parallel lines. So that is solving a 2x2 system of equations using elimination. I hope that you found the video helpful. If the video did help you in any way, and if you gained something from the video, please go ahead and give it a thumbs up. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.